Hello class, this is a video tutorial on linear functions part 3. In this video we will be looking at the equation of a line part 1. Linear functions can be represented in two forms. The first form being the gradient intercept form. You've probably seen this as y equals mx plus b in the past. It's a mere change of making this plus c and the y becoming the function notation. In this form, we can clearly see the gradient in front of as the coefficient of x and the y-intercept as the constant in the end. So for example, if we have this equation, y equals mx plus c, whatever value c is, it will cross the y-axis at the exact same value, this exact same y value as whatever this is. So here's a numerical example. We have y equals half x minus 3. So our y-intercept here will be 0 minus 3. The second form that we'll see is called the general form, ax plus by plus c equals 0, where a, b, and c are integers, and a must be greater than 0. So I'll show you in a few examples of what this might look like. This first one here is in general form. There are no problems. However, in this one, this value of this coefficient of x should be positive. Okay, and if you really wanted to, we can make it in simplest form. So for example, let's make this positive first by dividing everything by -1. So the signs will switch. It'll be 4x minus 12y plus 20 equals 0. And if we wanted to, we can divide everything by 4, giving x minus 3y plus 5 is equal to 0. Okay, so this division, this idea of making it simpler is optional. Okay, by dividing by 4. However, you can if you'd like to. The last example I'm going to show you here is that this idea of integers, they must be whole numbers. So a, b, and c must be whole numbers. As you can see, this is not a whole number. So to remove this half, I'm going to multiply everything by 2. This will give us 6x plus y minus 6 on 5 equals 0. Then lastly as well, this value of c, we'd like to remove this 5, this over 5. So we're going to multiply everything by 5. So we get 30x plus 5y minus 6 is equal to 0. So that's what general form would look like. Now, just as an exercise, we can convert between the two forms. So in this first one, let's convert these gradient intercept forms into general forms. It's a very simple process, and I'll demonstrate to you how to do this. So our y is already positive. I'd like to make this 2x positive. I'll do that by moving it across, making it a positive. So it'll become 2x positive plus y. Okay, and then let's also move this positive 3 to the to the left hand side of the equation, minus 3. We've moved everything from the right hand side. There's nothing left on the right hand side, leaving us with 0. Okay, let's move right along. In this example, we do not want any fractions. So I'm going to multiply everything first by 5, giving us 5y equals 3x plus 10 on 3. Likewise, this denominator of 3 I do not like, so I'm going to multiply everything by 3, giving us 15y equals 9x plus 10. Now notice, if I were to move this 9x to the left hand side, it will become a negative 9x. So since it's already positive, I'm going to leave it where it is, and instead I'm going to move this 15y from the left hand side to the right hand side, leaving us with 0. equals 9x minus 15y, that's my movement to this side, plus 10. Now just to make it neater, we can just let this all equal 0 on the right hand side instead. Let's do one more example here. In this case, once again, I do not like the fractions. Let's remove those by multiplying by 7 first. So 7y equals minus 3x minus 7 on 2. Same process. This denominator of 2 I do not like, so I'm going to multiply everything by 2. Get 14y equals negative 6x minus 7. And now at this point, I'm going to start moving things from the left and to the right, or vice versa. But notice how this negative 6x is negative. If I move it to the left hand side, it would become a positive. So I'm going to do that. So we're going to get 6x plus 14y. And since I'm already here, I'm going to move this 7 to the left hand side as well. So it will be negative 7 on the right. Moving it to the left will give us positive 7. And since I've moved this and this, there's nothing remaining on the right hand side, leaving us with 0. So that's converting equations to the general form. Now let's reverse this process. Let's go from general form to gradient intercept form. In this process, I always pay attention to my y value, because the y value should be isolated by itself. So in this case, if it's minus y, I'm going to move to this side, making it a positive y. So on the right hand side, it'll be y. And on the left hand side, everything else stays the same. And just cleaning this up, we get y is equal to 2x plus 3. There is my gradient intercept form. Let's do this one more time. Notice if I move this positive 4y to the right, it'll become a negative. So instead, I'm going to leave this on the left hand side and move everything else. So this positive 3x is going to become negative 3x once it moves to the other side. And this minus 2 is going to become plus 2. And now we're dividing out by 4. We get y is equal to negative 3 on 4x plus half. One last example here. Going to move this this negative 5y to the right hand side to make it a positive. So we get x minus 20 equals positive 5y. Cleaning this up, we get 5y equals x minus 20. Dividing by 5, we get y is equal to 1/5 x minus 4. So I hope that gave you an insight into the gradient intercept form, as well as the general form and converting between the two. Hope to see you in the next video. Best of luck.